Today's lesson is going to talk about two special kinds of logarithms. The first one is called a common logarithm, and that's just a logarithm whose base is 10. A log that doesn't look like it has a base is what we call a common logarithm. So for example, if you see log 100, we learned in our previous lesson that whenever you have logarithms, you're supposed to have a base, an argument, and then an exponent, but you need a base and an argument. And right now it looks like we don't have a base, but actually we do. It's assumed that if nothing's written, we're working with base 10, and that's because we live in a base 10 number system. So it's assumed that if you don't see a number there, that we're talking about base 10. So log 100 is the exact same thing as writing log base 10 of 100. Then you have what we call natural logarithms, and that's a log whose base is e. And because it's so popular to use e in calculus, instead of writing log base e all the time, we just simply write ln. So if we write ln of 14, that's actually the same thing as saying log base e of 14. So ln literally means log base e. Now the problem with some calculators is calculators were built with a base 10 number system. So if you want to evaluate a logarithm, unless you have a graphing calculator that has designated buttons to insert your base and argument, you're going to have to use what's called the change of base formula. So most standard scientific calculators require the use of this formula. So depending on what I want your base to be, you can change log base b of x to log x divided by log b. And I'll show you what that looks like here. So right here we have log base 4 of 16. That basically means 4 to the what gets you 16. So we know the answer's 2 ahead of time. But let's pretend we didn't know the answer. If you wanted to type this in your calculator, and again, if you're using a graphing calculator, most of them, especially the newer ones, have a way to type a logarithm in. But if you want to use the generic buttons, you can just write log x over log, or log 16 over log 4. Your other option is to use ln x over ln b, or ln 16 over ln 4. It doesn't make a difference, believe it or not, if you use logs or ln's. What you don't want to do is mix and match. You don't want to write log 16 over ln 4. You're either using logs or you're using ln. And if you type that into your calculator, you will get 2. Now, if you ever see that you have log with base e, you can certainly type this in your calculator, log 12 divided by log e. And once we're through this slide, I will show you how to type it in on a graphing calculator, but you could use that for a scientific calculator as well. You are certainly welcome to write that. There's nothing wrong with it, but it's so uncommon for us to use log, like log, with e. Anytime we see e, we really want to use ln. It just actually simplifies your workload. So ln and e are like best friends. So if you see one, you want to make sure that you use its friend when you're doing your calculations. That's kind of the way I would explain it. So instead of me writing log e, I could simply write ln 12 over ln e. Because we said up here, it doesn't matter if you use logs or ln's. So again, anytime I see e, I'm going to use ln's. And this is the reason why. I don't actually have to type all of that in my calculator. Believe it or not, ln of e is just 1. ln and e are inverses of each other, so they kind of, in a way, cancel each other out. So you can actually just change ln e to 1. So all you have to do in your calculator is type ln 12. So the first thing I want to show you how to do is log 16 over log 4. So you just look for the LOG button. And it doesn't matter what calculator you're using. It can be a basic scientific. Everybody has a log button. And you're just simply going to type 16. It's very important that you close your parentheses because you need to communicate to your calculator 16 is the argument for what I'm putting in right now. Now you notice the calculator didn't give you a spot to put the base. So right now this is assuming that we're in base 10. So that's why we were using this change of base formula. Then we're going to hit divide. And we're going to do it again, except this time we're going to hit log of 4. And then we're going to close our parentheses. And then we're going to hit enter and we get 2. So just to see what that would look like with ln, you could hit ln of 16. But you want to make sure you close your parentheses because 16 is the argument. And then we're going to divide that by the natural log of 4. And you can see you still get 2. Now, if we wanted to do log base e of 12, so this would have been the next example, we're going to do log of 12, and you want to close it, divided by log, and there's 2 ways to type e in. So on any calculator, there's an e to the x button. So if you hit second ln, it'll show you e with a spot for an exponent. E is the same thing as e to the first, so you can always just make it e to the first. That's the same thing as saying e. So that's one option, and then you would have to close your parentheses. The other option is to type your problem in, and I'm using a TI-84 plus CE, so depending on the model of your calculator, you might not have this, but I do have a just plain E button, and it's right here. I have to hit second divide. So there's going to give me the same answer. It's just a matter of convenience. So usually the newer the calculator, the more convenient things it has in it. So let's say we didn't use logs. Let's say we used ln's this time. So we still want to do log base e of 12. So what I really am doing is I'm doing ln of 12. If I don't want to use log, I have to use ln, natural log. And we're essentially dividing that by the natural log of e. It's going to be a really nasty decimal. But look what happens whenever you just type ln 12. You get the same thing. That's because ln of e, the natural log of e, is simply just 1. So anytime you have log base e, if you don't want to use that, you can just simply replace that with ln. So that kind of saves you a little bit of typing. It's a little bit easier to do. Next, I want to look into a couple different rules regarding these special logarithms. And the first one is that anytime you see log of 10, you actually can change that into 1. And here's why. Whenever we see log with no written base, we have to assume the base is 10. So log of 10 means 10 to the what gets you 10. So your base would be 10. You're thinking, what's the exponent so that my outcome or my argument is 10? So that's why it has to be 1. So that's why log 10 equals 1, because 10 to the first is equal to 10. Then we want to talk about why is ln of e also equal to 1? Again, we don't want to forget that anytime you see ln, that assumes that we're dealing with base e. So if we want to convert ln of e to exponential form, that would mean the base e to a certain power has to get you e as an answer. And the only power that's going to make that true is 1. So it strictly comes from what the bases are. So if you want to take the base to a certain power to get that same number, that power has to be 1. So in our next lesson, I'm going to go ahead and talk about what inverse properties look like in terms of logarithms and why they exist.